Hello everyone. This is the second class for ECO 320 Economic Statistics. Today we are going to start the main part of this course, main part of the main statistics. So it is chapter 1 titled as Probability. Let's get started. Oops. Yeah, let's preview what we are going to do throughout the semester. As I said last time in the last class, there are 12 chapters. First four chapters are about descriptive statistics, and then the next three chapters, 5, 6, 7, are about distribution models, and then the next three chapters, 8, 9, 10, are statistical inference methods. And then finally, chapter 11 and 12 are about linear regression model. So this is pretty much a standard organization of an introductory statistics textbook or class. So, but just I want you to see where you are going. Well, you can think the first four chapters as bundled together. So it would help to compare between them and where you are going. And to look at the first four chapters more closely. In the first four chapters, as I said, it's about descriptive statistics. It means how to describe the data, simply. How to describe the data or how to describe randomness. And there are two common ways to describe data or characterize randomness. And you know them. The first two chapters are about probability, and the last two chapters are about averages and a little bit of variation of averages. So you know what a probability is, what the averages are. So that's it. In statistics, just what statisticians do are basically a little bit of variation from these two. There is nothing like completely new other than probability or averages. So we are going to we will more carefully and rigorously define the probability and averages, and we learn how to use them when they are appropriate or when they are not, and then understanding the underlying structure of data or the randomness would help you to build the background for more applied work. So that is the main purpose of these four chapters. Just as I said, it's nothing new. I don't need to explain what is on average, but let's let's just do it more rigorously. What I'm going to do is a little more rigorously. It's not different from yours. And if you are if you want to read relevant chapters in textbooks, these are the relevant chapters about probability. Um, so depending on what you have, you can read these chapters, and I also refer these textbooks. And in this chapter, we will go through these main sections. But but pretty much it'll be pretty easy and just pretty elementary. So don't worry too much about the new words. Let's think about structure probability. We will define how probability is structured. So the simplest possible probability statement is this coin toss. The typical example: when you toss a coin, the probability of a head is 50%. It cannot be simpler than this. But let's think about this sentence more carefully. In this sentence, there are a few components, key components that any probability statement should have. First, of course, a probability statement should have a probability. That is this number, 50%, right? That is probability. Also, you have to define what is the experiment you are referring to. In this statement, you are talking about a coin toss. So that is the experiment. So if you drop this part, the probability of a head is 50%. Um, okay, it's okay, but but probability of head is 50% is incomplete, though you understand what it means from the implicit assumption. But uh, anyhow, you have to find out what is the experiment that defines this probability. And finally, you have to define the event of interest. I am telling you that if you do this experiment, the probability is 50%. Then probability for what? In this case, this is the probability for getting ahead. So if you have more complicated experiment, the probability and the event could be more complicated. So, but in this simple case, still you have to mention what you are referring to, where you are attaching the probability to. You are attaching 50% probability to this event, for this event to happen. So then so now we are going to study these components more carefully. Probability, so we will focus more on experiment and event. So we will study them because if you understand these two, then probability is easy to understand. So experiment, outcome, and sample space. That is the underlying terms. First, think about experiment. Experiment is an action or a process leading to a random outcome. And like without definition, you understand what it means. An outcome is an outcome from an experiment, and sample space is more non-casual term. Sample space is the collection of all possible outcomes. So when you toss a coin, there are only two possible outcomes, head or tail. Then the sample space is just collection of them, right? So sample space tells you what are the possible outcomes. And in other examples, other typical examples, when you roll a dice, oh, excuse me, it's a typo. When you roll a dice, you have six outcomes, and the sample space consists of six numbers, 1, 2, 3, 4, 5, 6. And when you inspect a part, then the outcome is either defective or non-defective. So then the sample space is just two outcomes. And when you play a game like baseball, basketball, football, whatever, then the possible outcomes are win, lose, or tie. And if you do a customer survey, then the outcome will be whether the customer is satisfied or not. Or the outcome may be more detailed, like how much satisfied in the scale of 10 or 5. So then the customer can choose any number between 0 to 10 or 0 to 5. Then the sample space could be larger, but you get and household income survey. If you survey household income, then the possible income is actually any number. Any non-negative number can be a household income. A household may earn nothing, zero, or another household may earn several billion or zillion dollars. So any number, any positive number can be the outcome. So depending on the structure of how you generate the random outcome, depending on what's your experiment, the sample space follows and it defines the possibilities. And then, so we defined experiment. Then we can define probability. The probability is the proportional times that the event occurs when an experiment is repeated many times. The keyword, keyword in this definition, I think is this part, many times. Otherwise, everything else is pretty much uh, well known, and without defining this, you understand what it means, what a probability is. But I'd like to think more about uh, this word many times. Ah, by the way, this definition probability is just actually one of several possible definitions in statistics. But I'm just telling you one definition because say 90% of statistic analysis is based on this probability. So we call this definition as the frequentist approach, and there are others like Bayesian approaches and something else. Uh, they exist, but it, it it's actually it does not matter, and it's more about philosophical differences and very subtle. So I think you don't need to know the different approaches at this level. Like if you are going to be a serious researcher, then it matters. But at the moment, at least in this course, it does not matter. So I'm not going to describe other approaches, but simply I will focus on this definition. By the way, coming back to this definition, as I said, repeating many times is something to think about. So then data are data are automatically defined. So data are observed outcomes from the repeated experiments. And we also define the number of repetitions as the sample size. It is very important term. Sample size, usually denoted as n, and this is the most important uh, component in statistics because no matter what statistical methods you use, the best best analysis is using the data with large sample size. So using the large sample size dominates everything else. Any method, any technique cannot overcome small sample size. So you have to understand that. So having enough sample size is the first and most important thing to do in statistical analysis. And you have to do whatever to increase the sample size. That is the best way to increase the accuracy of your analysis and quality of your analysis. Anyhow, so repetition of experiment is important. And look at this. This is simulated. I simulated coin toss on Excel. And if you throw a coin like once or twice, the probability of head is fluctuating a lot. So when you toss one coin, the probability is either 100% or 0%. And then it fluctuates a lot. And as the repetition increases to 1000, then it approaches to 0.5. So 0.5, we know it is a true probability, but even when you repeat 1000 times, it is not exactly 0.5. The probability is simply approaching to 50%, but still it is random. There is deviation from the true probability. That is the randomness. And this is the estimation error when you do estimation, and that's what we have to handle and understand. Okay, I will continue in the next video. We are going to define more important concepts in the next video. Thank you.